Welcome to The Explainer. Today, we're diving into a massive paradigm shift happening right now in the tech world. We're finally moving away from that old, expensive habit of relying on a single AI model for absolutely everything. Instead, we're uncovering why intelligent model routing is fundamentally transforming how companies manage their tech stocks. If you've been watching your AI expenses just balloon out of control and wondering how top engineering teams are bringing them back down to earth, well, you are in the exact right place. So let me ask you a quick question. Are you overpaying for AI? Because honestly, it turns out a lot of massive organizations absolutely are. Just imagine burning through your entire annual IT budget in a matter of months. It sounds crazy, right? But according to industry reports, major players like Uber reportedly burned through their entire annual AI budget by April of 2026. How does that even happen? It happens because companies are just defaulting to the most expensive tools for every single job, totally ignoring a major structural shift in how we can actually consume AI today. You see, we've all kind of fallen into this really costly habit. It's the old way of defaulting to the absolute smartest, most expensive Western frontier models, no matter what the task is. Need to solve a massive architectural logic problem? Use the frontier model. Need to fix a tiny typo? Still using the frontier model. But the new way is entirely different. It's all about intelligent routing across a mix of highly capable open-weight models. Basically, it's about matching the right tool to the task. Let's jump right into Section 1, the AI cost crisis. The era of simply paying top dollar for frontier AI without even looking at the receipt? Yeah, that's collapsing under its own weight. Just look at this number, 45 trillion tokens. To put that insane scale into perspective, total weekly token usage on platforms like OpenRouter was around 2 trillion back in July 2025. Less than a year later, by mid-2026, that weekly total exploded by more than 20 times to exceed 45 trillion tokens. With volume scaling that aggressively, an inefficient system doesn't just cost a little more. It creates an urgent existential financial crisis for enterprises. They literally have to rethink their AI spending. Now, you might think, okay, I'll just look at the price per million tokens to find the cheapest option. Well, actually, raw token pricing is a super deceptive metric. Databricks engineers discovered that token price absolutely does not equal end-to-end task cost. Why is that? Because larger, slightly cheaper per token models can sometimes be wildly inefficient. They might take way more steps, read more files, and generate double the tokens to solve a simple problem compared to a more focused model. You really have to measure the cost to complete the actual task, not just the raw fuel price. Which brings us to Section 2, Rise of Open-Weight Models. If we want efficiency, we need options, right? And those options have officially arrived in the form of highly capable, primarily Chinese-built open-weight models. When you compare a model like GLM-5.2 with Claude Opus 4.8, the contrast is just stark. For GLM-5.2, we're looking at $1.40 per million input tokens and $4.40 for output. Compare that to Claude Opus 4.8 at roughly $5 for input and a whopping $25 for output. That means these new open-weight models are matching frontier benchmarks at roughly a fifth of the raw token price. For cost-conscious enterprise deployments, a price difference of 4 to 6 times is just impossible to ignore. But remember what we just talked about? Token price isn't everything. So how does this actually look in the real world? Well, Databricks ran their own real-world coding benchmarks across millions of lines of code. The result? GLM 5.2 achieved frontier-level task completion at $1.28 per task, compared to Claude Opus at $1.94. That is a 34% lower cost per task. When your engineers are merging thousands of code changes a day, shaving 34% off every single task completely transforms your balance sheet. Let's get into the mechanics of this in Section 3, how model routing works. Okay, so let's really dive into this. How do we actually capture these savings without forcing our developers to stop and do financial math every single time they hit enter? The secret sauce here is model routing. By definition, this is the use of intelligent middleware gateways to evaluate incoming prompts and automatically direct them to the cheapest model capable of solving the task. The absolutely crucial point is that developers don't have to change their workflow at all. They just submit their code or prompt, and the gateway does all the financial and capability math in real time, totally behind the scenes. Behind the scenes, it all happens in 3 super fast steps. Step 1, the gateway pre-processes the prompt and checks the cache, basically asking, has someone already asked this? If yes, it just returns the answer for essentially 0 compute cost. Step 2, it evaluates the complexity of the request. Is this a deep logical planning task or just a simple summary? And step 3, it automatically routes the prompt to the cheapest capable model for that specific complexity tier. I absolutely love this triage analogy because it just hits the nail right on the head. Think about it. You wouldn't use a massive 18-wheeler to deliver a single pepperoni pizza across town, right? In the exact same way, you absolutely don't use a genius, ultra-expensive frontier model like GPT-5.5 or Claude Opus to just fix a typo, flip a feature flag, or update a simple config file. Using your most expensive asset for a routine operational task is a huge waste of resources. And the data backs this up beautifully. Databricks actually analyzed their own engineering workflows and grouped tasks into 3 capability tiers: high, medium, and low. What they found was wild. A staggering 61% of their engineering tasks were only medium complexity, things like routine coding and bug fixes. Only 12% were high complexity. So if you're defaulting to the highest tier model for everything, you are drastically overpaying on roughly 80% of your daily operations. That right there is exactly why tiered routing is so incredibly effective. So who is actually doing this? Let's look at Section 4, Real-World Enterprise Savings. 50%. That is a massive number in the enterprise world. Coinbase literally cut their total AI spend by a staggering 50% simply by defaulting their engineers to GLM-5.2 and Kimi 2.7. The brilliant thing is they didn't even take away the frontier models. They just stopped using them as the default for every single query, and their costs plummeted, even while their overall token usage continued to climb. Let's break down exactly how Coinbase pulled that off. First, like we mentioned, they routed those routine operations straight to the highly capable open-weight models. Second, they enforced strict context hygiene. What does that mean? It means developers were trained to close inactive tools and not just blindly dump massive, totally irrelevant code bases into their prompts. And third, through better infrastructure, they cranked up their prompt caching hits from a baseline of just 5% all the way up to 60%. When you hit the cache, you're returning stored results at near zero token costs. There's another massive piece of the efficiency puzzle here, which Databricks discovered, and it's all about the developer harness. The harness is basically the framework or agent environment the developer uses to actually interact with the model. Databricks found that using a minimalistic, lightweight harness, like one called Pi, sent 3 times less context per turn than heavier native harnesses. It kept the working set really tight, resulting in tasks being completed for up to 2 times cheaper with the exact same quality. So model choice is only one piece of the puzzle. How you talk to the model matters immensely. Now, we have to talk about the elephant in the room in Section 5, geopolitics and data security. As we discuss these incredibly efficient Chinese-built open-weight models, the geopolitical tension is very, very real. The U.S. Department of State has actually issued warnings to diplomatic posts worldwide, stating that adversaries' extraction and distillation of U.S. AI models enable foreign actors to release products at a fraction of the cost. The core concern outlined by the U.S. government here is that these low-cost models are essentially built by siphoning the outputs of expensive U.S. proprietary models, and in that process, potentially stripping away security protocols and ideological guardrails. So how are Western enterprises safely utilizing these tools given all those warnings? Well, the key really lies in the licenses. Models like GLM-5.2 and Qwen release their open weights under highly permissive MIT or Apache 2.0 licenses. This allows companies to bypass those data security risks entirely by just downloading the model weights and self-hosting them on their own private US or EU infrastructure. By combining this with zero-trust architectures, where no network connection is ever trusted by default, and central routing gateways, a company's proprietary code literally never touches a foreign server or a public API. But, of course, there's a catch. And it's the hardware reality. While the license totally lets you download the model, the physics of actually running it are pretty daunting. Self-hosting a flagship 753 billion parameter model like GLM-5.2 requires massive physical infrastructure. We're talking over 1.5 terabytes of GPU memory just to load the weights. For a lot of organizations, this pushes them toward hybrid cloud solutions, simply because building out a massive cluster of high-end GPUs locally requires a huge upfront capital investment. And that leaves us with a final, really important question to consider. In the battle for AI dominance, is your enterprise going to choose frontier loyalty or economic efficiency? The structural shift is already here. The tools exist right now to slash AI budgets by 50% or more without sacrificing quality, just by matching the right model to the right task. It might just be time to evaluate your own AI stack. Thank you so much for joining me today, and I'll catch you in the next explainer.